Welcome to next session. This session is the continuation for the application layer protocol. Till XMPP we have seen in the last session. Next application layer protocol is AMQP, Advanced Message Queuing Protocol. So this application is an open layer for business messaging. Basically AMQP is used for business purposes like banking. If you want to transfer the money, NEFT transfer, for this AMQP protocol is used. It is the advanced protocol. It supports both point-to-point publisher subscriber models, routing and queuing. So these are all the different types of models it supports. It supports point-to-point. Point-to-point means communication to communication from one point to another point using the frames here. Here also it uses frames. Frame is a main thing in this AMQP protocol, where you can connect the link between one client to another client. You can attach the link or you can detach the link. You can open the session, close the session, like that you can do. That is called as point to point. And public subscribe model, as we seen in MQTT, it also supports public subscriber model. Next, AMQP brokers receive messages from publisher. As it uses public subscriber. Wherever you are using public subscriber, we use the word broker. Broker is a key word which is a server between publisher and subscriber. Now messagings are either delivered by the broker to the consumer which have subscribed to the queues, or the consumers can pull the messages from the queues. What is this queues? We will see in the diagram. The next slide. So the AMQP protocol enables the different types of programs which deals and engage with the AMQP model. So in the next slide we will see the diagram. The main components are exchange, message queue, binding. What are this exchange, message queue, binding? We will see in this diagram. This is the architecture of AMQP, where you have different publishers. Publishers are the one who will collect the data from the sensors, and this is the broker. It will send to the subscriber. Whoever is subscribing to the broker, for that particular correct client, the publisher will send the data through the broker. But inside this broker, as it is advanced one like MQTT, if you see, you have subscriber, broker, and then the publisher. But here you have something in advance within the broker, where exchange is the one from where you are going, all the publisher will send data to the exchange. From exchange you are going to send data to multiple queues. You have different queues here. So here it is going to send the data from exchange. It is routing data to the different types of queues. So the working of this broker inside is based on that, what is the type of the data that is asking, and what is the type of data. It is organized in different queues here. So here you have two things here. You have different types of frameworks are being used. Like if you take it as a direct means you are having a routing protocol here, and you are having a binding protocol. 000 from publisher to exchange, it is called as routing protocol. From exchange to queues, here you are having 00 binding protocol. So direct means if binding protocol matches with the routing protocol, then to that particular queue only the data will be sent. Like this, the exchange will decide to which queue you need to send the data. If it is direct, it will check whether the binding protocol is equal to routing protocol. If you use fan out means whatever the data it is getting from the publisher, it will send to all the queues which are bonded to that. In this diagram, if you see, 3 queues are bonded to that exchange. That's why whatever the data you are getting from publisher, it will send to all the queues. That is called as fan out. You also have called header type. Header type, it will check the type of the header data, and if it is matching, it will send to that particular queue only. So this is the way it will decide. The exchange will mainly decide to which queue you need to send the data, and from the queue every subscriber is subscribing the information which is there in the queue. Who is subscribing for that particular subscriber, correct client, it will route to that particular subscriber through queues. That is the meaning here. We have learned one particular sentence here. Messages are either delivered by broker to consumer which have subscriber to the queues, or consumer can pull the messages from the queues. That is the meaning here. Pull the messages from the queues. Subscriber will pull the messages from queues, and here exchange will take data from the publisher. So this is the working of AMQP. Next type of application layer protocol is DDS. data distribution service. Here data is distributed. What is the data here is basically device data. Device data means an Android phone talking to the Google Assistant or Siri, like that. It is also basically used for machine to machine communication. Like COP, this is also used to machine communication with less human intervention. Next, public subscribe model. DDS protocol uses public subscriber model. So, publisher here means IoT device which generate data from the IoT, creating the topic to which subscribe. Public subscriber, every time when you see, you will get the broker, the word, and then topic. Broker, through the topic it will send to the correct client. Provides quality of service. It also provides configurable and reliable. It is very much useful. It is very efficient. It can be useful in the defense domain. DDS makes use of multicasting to convey high quality service to applications. So, DDS is high quality application services where you can use in defense data or in a confidential data like healthcare. These are all the applications of DDS. So, till here different types of application layer protocols are completed, and the last topic okay. So, the DDS architecture should also be explained before going to the next topic. So, the architecture here is operator human interface, enterprise integration, real time analytics and control. That means these are all the applications, and this line is called as data bus. Above the data bus are different types of applications. Below the data bus are sensors and actuators which work accordingly to the data passed to it. So, here if you want to integrate some operations or real time analytics, if you want to do, which you want to see in our monitor, so you can use sensors and actuators through this data bus. So, this is one of the protocol which is very highly reliable, highly efficient, which is used in main defense type of applications. So, as I said, that was the last topic in application layer protocols, and last topic in unit 1 you will see subtopic as applications of IoT. What are the different domains in which we can use IoT, but here we will end up with only one slide, because in unit 5 you will be having detailed of every application. So, just here in brief, different types of applications. IoT can be used in smart homes, IoT can be used in smart cities, environment, energy, retail, logistic, agriculture, industry, health and lifestyle. This is a diagram for applications and different types of domains where IoT can be used. This we will see in detail in the 5th unit. Thank you.